What's up, guys? Welcome to trèSci Weekly, episode 10, the double digits of doom, Tom.
Number 10, we made it.
I'm one of your hosts, Jonathan Ullman, alongside the fruit of the loom.
The fruit of the loom.
Tom Kea.
Thanks for having me.
My pleasure,
Every
dude.
day.
Thanks for being
every
here.
week.
Oh, yeah. What's going on, man? How are you?
Doing good. Been enjoying the warm weather.
Yes, indeed. Finally.
Feels good to be able to walk outside and not have your face hurt from cold weather. You know?
Yeah, I thought it was never going to stop raining last week for a little while.
That's true, too.
I know.
Did you hear the thunderstorm?
No.
No? There was crazy thunder at my house.
Really?
Yeah, like enough to shake the house.
When?
Last week when it was raining.
Huh. I missed this. I missed
You
this.
must have been somewhere else.
Yeah, I guess. New Mexico or somewhere crazy. No, I'm just kidding. What's been going on, brother guy, dude? Anything notable, noteworthy?
For the show?
Yeah, well, just personal, I guess.
Not really. Just been trying to stick to exercising, you know.
Cool.
Living the good life.
Right on.
How about yourself?
Yeah, same here. Let's see. Kyle and I went out, when was it? 2 nights ago, or last night? Was it last night?
Jupiter?
Yeah. Last night.
Last night checking out the Jupiter at opposition?
Yeah, so we missed opposition because it was cloudy. That was
okay.
the night
before.
That was 2 nights ago. And then last night, took the scope out, saw some jupes, saw some of the Galilean moons.
Could you resolve anything out of it? Because I think we looked at Jupiter before.
Yeah.
And it's tough to see a whole lot of detail, but
you get a little.
You can tell it's Jupiter, though, right?
Yeah. My telescope's cheap and crummy, but you can see some of the equatorial bands there, a little color, right?
And you could see the dots of the moons too.
Yeah,
right? Yeah,
so
which is cool.
That's my favorite part, right? Because you see the equatorial plane is like this,
Tilted
right?
like that.
And then if you compare that with the phase of the moon, which was a gibbous, a waxing gibbous, I want to say. And then, you think, all right, so that's what the moon looks like. And then the sun obviously must be down beyond the horizon over here. And you really get a sense of wow, I'm standing on a curved planet, in the northern hemisphere. If we oriented everything back up this way, then it would all be in line with everything. But
gotcha.
yeah, I don't know, it's just kind of a weird realization.
The way all the space geometry
Exactly. You really feel it for a second when you see it all kind of in the sky. So Kyrie Irving can come on over here if he doesn't believe
and the Earth is round.
Yeah, exactly. Just 6 stories this week, Tom. Not a whole heck of a lot of
breaking news, or
there is actually a little bit of breaking news, but not a lot of a lot of content this week, but a lot of conversation, I think.
Good in depth.
Yeah. If you're joining us, welcome. This is trèSci Weekly. Tom and I do this weekly video series where we like to talk about science news and all the kind of ramifications of it. You can help us out by chatting with us in the chat. You can come join us in our YouTube live chat.
Come say hi.
Come talk about what we're discussing. You can subscribe to us on our YouTube channel. That would help us out a lot.
Yeah.
We've been kind of at a standstill with subscribers, so I'd love to bump that number up because we're on that climb to 100 to get the link, and it's been steadying off a little bit. So if you guys haven't subscribed yet, make sure you
tell a
subscribe.
stranger also.
Yeah, tell a friend. Tell a friend. You can also go to facebook.com/trèSci Weekly. Give us a like there and follow kind of the stuff that I put up throughout the week to kind of add to the experience, if you will. You can also follow us on Twitter at twitter.com/trèSci Weekly, where Tom kind of mans the ship over there, tweeting out fun stuff, retweeting some of the articles that we talk about later on the show.
If you want to get a chance to browse over them.
Exactly.
It's always easier to understand when you already have an idea of what's happening.
Exactly. And you can also support us financially if you choose to do so at patreon.com/trèSci Weekly, where you can pledge a monthly subscription of any dollar amount you wish. That goes to help kind of improve the content, improve the quality of the stream, and just kind of
Yeah, keep us bringing you the science news.
Keeps the dream alive, basically. With that said, let's get right into the news there.
As we
do. Number one, Tom.
Yeah, number one. It's a good one.
It's a good one. I didn't see this circulating around all that much. I just kind of found this story in one sort of spot. But here we go. The TRAPPIST-1 system, the solar system with 7 terrestrial planets located approximately 40 light years away, may not be suitable for hosting life after all.
So this is the same solar system that we spoke about with the NASA press conference with the 7 exoplanets that were all considered to be in the habitable zone.
Exactly.
Same TRAPPIST system.
Yep.
Not TRAPPIST number 2.
Not TRAPPIST-2, TRAPPIST-1. Numero uno. Still that guy. A recent study led by astronomer Christian Vida and colleagues at the Concolli Observatory in Budapest suggests that the host star TRAPPIST-1 may spit out violent flares too frequently for atmospheres to stabilize on any of the orbiting planets. By examining photometric data obtained by NASA's Kepler Space Telescope K2 mission, the researchers analyzed 42 high-energy flare events where, quote, the median waiting time between consecutive flares on TRAPPIST-1 is 28.1 hours, end quote.
So there's a pretty violent solar flare almost every 24 hours on there.
Exactly.
And like we said last time, these exoplanets are within the radius of Mercury relative to our sun.
Mm-hmm.
So they are really close to the Earth, so that flare would have quite an impact on these planets' ability to have atmospheres and to just exist to hold life. Right?
Yeah, due to that proximity, they're getting blasted with high energy radiation, and
so is that enough? Just those solar flares to eliminate life on them?
Well,
what do we see here?
Let's keep going. Let's see. So they calculated that frequency, right? 28.1 hours. Then, by calculating the total energy of each flare event and comparing that to the relatively lower flux energy of TRAPPIST-1 during quiescent periods, the team was able to determine, quote, a rudimentary estimation of how such eruption changes temporarily the limits of the habitable zone, end quote. Since the planets orbiting TRAPPIST-1 are much closer to their host star than Earth is to the Sun, magnetic storms can be 100 to 10,000 times stronger than the strongest geomagnetic storms we've experienced here on Earth. This means that in order for an atmosphere to exist on any of the planets orbiting TRAPPIST-1, they would necessarily need magnetic fields of their own that are at least 20 times stronger than Earth's for protection.
So they would need a super strong magnetic field to stop those flares from impacting them. So is it likely that they could have a magnetic field that strong?
It's possible.
Like, it's theoretically possible, but...
Well, I actually don't even know if it's theoretically possible.
Because it would have to be made up of a large metallic or like iron content and have some sort of crazy dynamics to make that large of a magnetic field. Right?
Yeah, so
it's extremely likely. Yeah.
If I'm not mistaken, we believe that the Earth's magnetic field, which is a relatively strong one, about half a Gauss, right, is generated because there is this dynamo effect between the solid core of the Earth and the liquid mantle surrounding it. So it kind of churns the liquid as it kind of moves around.
And that movement is what creates the magnetic field.
That's what they think. I don't know. I don't know how set in stone that theory is, but that's kind of the best as I understand it. And we don't really see such strong magnetic fields elsewhere in our own solar system. So
it would be pretty unlikely.
Yeah, so this is unlikely, and thus doesn't bode well for life to exist within the system. We'll still find out if any atmospheres do exist on any of the TRAPPIST-1 planets, despite the frequent flaring when NASA's James Webb Space Telescope launches in October of 2018. So image credit goes to NASA for the graphic of TRAPPIST-1, and we've got a little video here from NASA Goddard Space Flight Center. This is going to be a video that dates back to, I believe, 2012, looking at our own sun, which is emitting some pretty hefty flares there, Tom. I just wanted to show the good people what we're talking about.
Look like.
Yeah, when we're talking about solar flares. So, Kyle, you let me know when to hit play on this bad boy.
And you can actually watch a live stream of the sun. They put mosaics of it up on YouTube.
That's true. We were checking that out before. Don't go into their chat, though.
No, it's canceled. So these are actual images of the sun, correct?
Yeah, so this is going to be a compilation of data and images from a few different spacecraft that are observing the sun. I want to say... Yeah, so NASA's SDO, Solar Dynamics Observatory, NASA's Solar Terrestrial Relations Observatory, or STEREO, and the ESA NASA Solar Heliospheric Observatory, or SOHO. It's kind of a collection of different images all looking at the same flare and resulted coronal mass ejection.
Pretty impressive.
Pretty crazy looking.
So then it would be these solar events, because the planets are so close, that it would strip away their atmosphere, right? It would just kind of brush it away.
Exactly.
Because they're pretty intense. And the only thing that protects our planet is our magnetic field. But for how close they are, it's very unlikely they have a strong enough magnetic field.
Right. Yeah. I mean, if you're right up next to a mass ejection like that, I mean, it's like looks like a gunshot just going off. Just
yeah. With fire.
Yeah.
Yeah.
Yeah, this one really really shows it.
That's in like a different wavelength.
Yeah.
So they're trying to show it in various wavelengths to get an idea of what it looks like.
Exactly. So, that is kind of unfortunate news. We were discussing a little bit amongst ourselves, Tom, back when we covered this original story about the NASA press release about the TRAPPIST-1 system.
Yeah.
We kind of made some predictions about what we thought might be the follow-up reporting of it. Neither one of us predicted this.
Yeah, we didn't predict that it is unlikely to have atmosphere or life on any of the planets. We weren't really that dismal or negative in our predictions, but what we did say, I remember saying personally, was that don't get discouraged if we get some negative news about this system, because they give it so much praise. Like, this is such a cool system, 7 planets, and the possibilities of life is endless in the universe if there's more systems like this. And then less than 2 months later, there's good evidence, that this isn't a good solid system for life now.
Yeah.
So,
do you think that NASA jumped the gun a little bit with their release of the information?
Yeah, so we spoke about that before too, and you mentioned it earlier today. Like, how could you have this press release and not check the light curve from the sun to see what it's doing, right?
Yeah, so
doesn't that seem a little weird to make that?
Yeah, I mean, I'm sure people were looking at
they were checking
the light
it
curve,
out, yeah,
but maybe not to this detail. It just still seems to me like a little bit, maybe emotions got the best of them.
Yeah,
where,
like we were saying, they were very excited with their find. They wanted to publicize it.
Yeah, and we, as humans, we are always attracted to the idea of finding life outside of Earth, right? And whenever there is some news that can increase the odds of us maybe finding it elsewhere, I think that those sort of news stories make a big splash. And so
yeah, it's a good headline.
It is a good headline. Unfortunately, it doesn't really seem like this system is going to work out to be a candidate for hosting life due to these flares. But that is our own bias again, right? As I was saying to you earlier too, that it'll be interesting when James Webb Space Telescope does get some spectral data from the planets, and maybe there is some atmosphere that exists on one of them, and then it'll really kind of change our perspective on how an atmosphere can be held on the surface of a planet. So
so like I was saying, don't give up.
Right.
Don't give up.
I won't give up.
Yeah, that's good.
You better not give up.
I won't.
Shall we move on?
Yep. I just want to give a shout out to the chat. Thanks for showing up, guys. If you have any good comments or questions, feel free to ask.
Of course. That is the point of the chat. All right. Moving on.
Number 2.
More space news. Lots of space news this week.
It is a good week for space.
NASA's Cassini spacecraft, which has been providing incredible images of Saturn and its moons for us since 2004, will begin the final phase of its mission on April 22nd. According to NASA's Cassini webpage, quote, after almost 20 years in space, NASA's Cassini spacecraft begins the final chapter of its remarkable story of exploration, its grand finale. Between April and September 2017, Cassini will undertake a daring set of orbits that is, in many ways, like a whole new mission. Following a final close flyby of Saturn's moon Titan, Cassini will leap over the planet's icy rings and begin a series of 22 weekly dives between the planet and the rings. No other mission has ever explored this unique region. What we learn from these final orbits will help to improve our understanding of how giant planets and planetary systems everywhere form and evolve, end quote. We can take a look at an animated video by NASA's Jet Propulsion Laboratory that details the grand finale. So,
let's check it out.
Lots of videos this week. Kyle, if you'd be so kind as to give me the point. Here we go.
A lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
5, 4, 3, 2, 1. And liftoff of the Cassini spacecraft on a million-mile trek to Saturn. We have cleared the tower. Its program is in. Full program is in.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
To the SOI burn attitude or pointing position and light up the rockets.
The spacecraft carried a
How many
passenger,
years did it take to get to Saturn?
the European
Seven
Huygens
years.
probe, the first human-made object to land on a world in the distant outer solar system.
Huygens arrival on Saturn's moon Titan.
For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings.
So between Saturn and the rings. Pretty
As it
precarious.
repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
Yeah, I'm loving these science videos that are kind of like movie trailer-ish.
Yeah, right?
I love them.
All right. So that is going to be very sad Tom. That's going to be a very sad day.
That's what Andy Dunscombe said in the chat.
Yeah.
It's kind of sad. Poor little guy working all alone for years.
Yeah. Now, Cassini has been one of the, I would argue, most successful scientific probes that we've kind of sent out into the solar system.
Lengthwise and just
the
data we've received.
Yeah, the
it's
amount
very
of
successful. Yeah,
exactly. The amount of information we've gotten from that mission alone has been just astounding. And Saturn is really the crown jewel of our solar system. I mean, what an awesome planet to study.
When you're a little kid, everyone is like amazed by Saturn.
How can you
the
not?
Huge rings? You're like, whoa, man.
Yeah. So I like that this video kind of humanizes the spacecraft in a sense, because it's really going to be a touching moment. I'm sure this will kind of make larger news headlines at the time in September when it finally goes dark. It reminds me a little bit of the Philae lander from the Rosetta mission that landed on the asteroid Vesta, and upon landing it kind of lost radio transmissions, and their official Twitter was tweeting out like, oh, my last few moments here, and like it really humanized the whole experience, and people were genuinely sad about it. And I think that's going to be another situation here where, you know, it'll be
people work their whole lives using this data, right?
Yeah, of course. So that's going to be awesome, though, as Cassini kind of makes these 22 passes in between the rings and the planet proper, right?
So it's making all those loops because it's slowly lessening its orbit to get closer to Saturn.
Right.
I believe like as it's making these loops, it's in between the rings and the planet Saturn, and as it makes these orbits, it's getting closer and closer, and then during the last orbit, it's going to get, with enough gravity, go into the Saturn and get destroyed there. So they mentioned in the video they want it to be destroyed on Saturn and not one of the moons that could be harboring life. And I never actually thought of that until I read this article. I was like, oh yeah. I mean, I guess you got to take that into account.
Yeah.
Like, you don't want to smash something into like a planet if you don't have to.
Exactly.
So when it's going into Saturn, which is primarily made of gas, it's just going to get ripped up by the gravity.
Right.
Okay.
So, so, you know, so as to not contaminate anything that might be on any of the moons that have a surface, it makes sense to just let
it go somewhere
Saturn's
else.
Gravity do the work. It'll destroy it into a million pieces.
They think of everything over there, though. You know?
Oh, yeah. So, some breaking news, Tom.
Yes, this is good stuff.
We saw just before on Twitter, NASA has announced that they will be holding a press event at 2 p.m. Eastern time on Thursday, April 13th, to reveal new discoveries on oceans beyond Earth. Quote, NASA will discuss new results about ocean worlds in our solar system from the agency's Cassini spacecraft,
which we were just talking about,
and the Hubble Space Telescope during a news briefing 2 p.m. Eastern Time on Thursday, April 13th. The event, to be held at the James Webb Auditorium at NASA headquarters in Washington, will include remote participation from experts across the country. The briefing will be broadcast live on NASA television and the agency's website. These new discoveries will help inform future ocean world exploration, including NASA's upcoming Europa Clipper mission planned for launch in the 2020s, and the broader search for life beyond Earth, end quote.
So, what was their last press conference about? We were just talking about it in our first story.
Yeah.
You know, their big press conference was the TRAPPIST star system.
Yeah.
Where we found these 7 exoplanets. And our first story was kind of knocking that.
Yeah.
And we were kind of saying, like, how many press conferences can NASA have? And, like, how many have to be successful until people, like, stop listening to them? You know, kind of thing.
Yeah. So, this...
Are you excited for this one?
This does excite me because I think we can speculate a little bit here. They want to discuss ocean worlds in our solar system, and they're going to use Cassini and Hubble to kind of present that information to us. If they're using Cassini, then it has to be a moon of Saturn's.
Yeah.
And so I think what we're going to be talking about is Saturn's moon Enceladus, because that has been kind of theorized to have a liquid ocean underneath a sheet of ice.
Yes. So maybe they have new news of the ocean world.
Yeah, I would be very surprised
If it was something else.
Well, I'm sure that they're going to talk about Europa, which is one of Jupiter's moons, which we also know has a liquid ocean underneath a solid surface of ice. If they're going to talk about the Europa Clipper mission, then obviously they're going to talk about Europa.
Yeah.
But the fact that Cassini is in there means they have to be talking about multiple ocean worlds.
Yeah,
right?
so maybe what they learned from Cassini around Saturn on one of those moons, whatever they learned about the ocean there might be applicable to looking for oceans and life on other moons and things.
Yeah.
So maybe they're saying, this is what we learned, this is what we got, and we might be able to apply that to these other missions studying other moons that have ocean-like conditions on them.
Yeah, that's a fair point.
So
yeah,
we'll see what they got for us.
We'll see. I'll be watching it live, I'm sure.
It's cool to have press conferences, though.
I like it. I like
too.
that they make a big splash. Like we were saying, they just have to make sure that they get kind of all the information they need to do so before they announce things. Any other final words on that, Tom? Or shall we move on?
Yeah, we can move on.
Okay. Number 3. This past week, the Event Horizon Telescope and the Global Millimeter Very Large Baseline Interferometer Array, which I'll abbreviate to GMVA from here on out, have begun making observations of what will hopefully be the first images of a black hole.
Pretty exciting.
Pretty exciting. To do this, an international network of radio telescopes have teamed up to perform a technique known as Very Long Baseline Interferometry. By linking telescopes across such large distances, astronomers can significantly increase the resolution of their target. This is crucially important since the target in this case is the supermassive black hole at the center of our Milky Way galaxy, known as Sagittarius A. And despite being about 20 times larger than the size of our Sun, it is located approximately 26,000 light years away. So, 20 times larger than our Sun, that's large. But when we're talking about astronomical...
That's not like huge.
That's not that large.
But for a black hole.
For a black hole, that's very big, right? That's very large.
It's like a condensed thing, it's a condensed singularity.
Yeah.
So for it to be that big, right, that's got to be a pretty massive...
Yeah. So it's a galactic black hole.
Yeah,
right?
it's at the center of our galaxy.
Yeah. There are stellar black holes, and then there are galactic black holes, which are probably black holes that have merged, right?
Yeah, in the center.
Or eaten up lots of material. But just to make that point that, it's so far away that we basically need a telescope the size of half the Earth to look at it.
Yeah, we take them all up and team them together.
Yeah, link them all up and increase the spatial resolution. And it's a very, very nifty technique. I know a little bit about it because in my astronomy senior lab class at Stony Brook University, we made use of a makeshift interferometer to get a nice angular resolution of the Sun and compared that to just a single dish thing. That was kind of like our big project. Very nifty technique. The math is so complicated, so I can't even imagine putting in so many radio telescopes. What an incredible project this is going to turn out to be. Coupling the size, Tom, with the fact that a black hole does not emit any light of its own, suddenly it becomes clear that this will be a very challenging image to take. Luckily, the goal of the Event Horizon Telescope and the GMVA are to image the quote-unquote shadow cast by the event horizon of Sagittarius A. Quote, Einstein's theory of general Let me try that again. Einstein's theory of general relativity predicts that there will be a roughly circular shadow around a black hole. The EHT aims to image the shadow to test this prediction and determine the mass of black holes, end quote. In addition, the GMVA will attempt to find out more about how gas and dust material accretes around a black hole, as well as the formation of jets that eject material back out of them. Of course, astronomers will need lots of data crunch before the results are expected to become available at the end of 2017. Image credit goes to ESO and Oliver Furtak for the infographic, and Demetrios Saltis and Avery Broderick for the simulated Event Horizon shadow image. Tom. So we can take a look at those images over here if you want to see what we were talking about. So this is the network, and here are the shadow images. So that's what we expect to see.
It's gonna just look like this.
It's gonna look
shadow circular type black hole type thing.
It's gonna look like a black hole. Yeah.
Yeah, it's just a circular black hole.
Yeah. So the image itself isn't the flashiest, I guess.
So they're not looking to really study these images. They're trying to study the data they're getting back.
I think so.
Amongst various other things, not just trying to get a nice picture of one.
Yeah. It'll be interesting, right? These are simulated images.
It'll see what it actually.
Yeah, it'll be interesting to see how it might, potentially differ from the simulations.
Yeah, it's not. Simulations are nowhere near perfect.
No,
so
yeah, we'll see. I'm sure we'll get a lot of interesting science out of this project because we've never been able to really look at a black hole before. So
yeah, and the point this article makes is that there's going to be so much data that it really just requires a lot of crunching and going over it to make sure that they know what they're getting.
Yeah.
It's going to be a lot of man work.
Definitely.
And hopefully they don't have another press conference like them and blow all their shots before they know what they're talking about.
Yeah. So we'll see.
All right, moving on.
Mike DeRamo, longtime friend of the program, shared a story with trèSci, just like you can.
Yep.
He actually shared this with us last week, Tom, but we didn't
get to it.
9 stories already, and he shared it kind of on Monday last week, so I said, we'll save it for this week. But it's very interesting nonetheless.
Yeah, so if you come across any cool science you see, you can just tag trèSci and we'll see what you see.
On Thursday, March 30th, the Chandra X-ray Observatory announced they had captured a mysterious flash in a region of the sky known as the Chandra Deep Field South. The strange source happens to be the deepest X-ray source ever imaged, and its properties are significantly unique enough that astronomers postulate it may be due to an entirely new phenomenon. As with what seems like many other types of astronomical observations we report on, the X-ray source was originally detected back in 2014 by accident. The first team was not even looking in X-ray wavelengths when they discovered it. Yeah. But when the source became 1,000 times brighter over the course of a few hours, this prompted the Chandra team to investigate. Over the course of a day, the source had faded to below Chandra's sensitivity, however. Using legacy data from the Hubble and Spitzer space telescopes, the source was pinpointed to a galaxy located about 10.7 billion light years from Earth.
Oh, that's it?
No, that's it. Yeah, that's not very far. A further puzzling detail that Franz Bauer et al. Point out in their recently published paper is that there seems to be a lack of any gamma-ray burst detection, which usually goes hand in hand with X-ray source flare-ups like this one. Bauer's team hypothesized 3 scenarios to make up for this. Quote, a few theoretical possibilities remain. A quote-unquote orphan X-ray afterglow from an off-axis short gamma-ray burst with weak optical emission, a low luminosity gamma-ray burst at high redshift with no prompt emission below around 20 kiloelectron-volt rest frame, or a strongly beamed tidal disruption event involving an intermediate mass black hole and a white dwarf with little variability. We stress that each scenario likely requires considerable fine-tuning to comply with all of the constraints, end quote.
Yeah, so they offer up 3 possibilities that are all quite different, actually.
Yeah.
And they still say that none of them actually match all of the things that they're observing.
Right.
So this is quite a little mystery.
Little conundrum here. So I guess if we want to go through the different scenarios, they're saying that this could be some X-rays left over from a gamma ray burst where it's not facing the Earth, right? So we're getting kind of some leftover radiation that didn't kind of project in our direction. That's one possibility. It could be a low luminosity gamma ray burst at high redshift, right? So something so far away and not actually very bright in gamma rays, basically. So we wouldn't see emissions with this energy kind of right away due to the way like space-time kind of works, right? Mm-hmm. Light only travels at a finite speed. So so that would be the second option there. And then the third option would be a tidal disruption event, basically the destruction of maybe a white dwarf star that doesn't have much variability, as it gets gobbled up and ripped
By a black hole.
apart by a medium-sized black hole. So,
Yeah, they offer some
options here. I think it's safe to say that it's got to be a cataclysmic event, right?
something
Because
being destroyed. Yeah,
you need really, really high energy to produce X-rays. So it's got to be something crashing into each other or something like crazy like that. But since none of the scenarios can fully explain what the astronomers have observed, it is quite possible that this X-ray source comes from some new astrophysical event that has yet to be explained. Animation credit goes to Chandra X-ray Observatory for the little kind of flare-up
flash
that we see. Yeah. So, what do you think it is, Tom?
Yeah, this one was kind of weird. I thought about it for a little while, and it's one of those things where I'm not a crazy cosmological expert or anything. I don't have any new theories or ideas to add to it.
Sure, yeah, me neither.
But yeah, it's just like it's cool to a little flash comes up and you don't know what it is. Like getting into science research these days, a lot of people think it's cut and dry and you do this and you do that, and it's cool to see cool unexplainable phenomenon out there that you can take a look at, even if they are 10 billion light years away.
Yeah,
Pretty
yeah.
cool.
This has got to be really fun for a theoretical astrophysicist,
To try
right?
and
It's
work
like,
on what could this be.
yeah. So we have these things that we observed. What could it be, right? Like what fits the criteria? It's very different from kind of how it typically works, where
they would explain a phenomenon and then you look for it,
right. You have theorists who mathematically work out, right? Okay,
what it could possibly happen.
Yeah, if this worked this way, then we might see something like this, and then you use your telescopes to look for it.
Look for that. Yeah,
Yeah, it's fun when it works the other way
And
around.
you just happen to see something.
yeah, totally. Cool. All right, shall we keep moving?
Well, let's keep moving.
All right, number 5. James Farrell, also longtime friend of the program, and congratulations is in order, Tom.
Oh, yes.
James passed his qualifying exams for his PhD, so I think all that's left for him now, correct me if I'm wrong in the chat there, James, all he has to do is his dissertation now.
Yeah, just a quick little dissertation.
No problem, right?
And then you're good to go.
No, but congratulations,
Yeah, but
man.
awesome, yeah.
Very awesome. You're making us proud over here at trèSci. He tagged us in a live stream by the American Geophysical Union in conjunction with the Syracuse University Lava Project. A series of lava pours were filmed right outside one of the university's buildings in order to research how lava moves across different slopes of sand. And we're going to take a look
at some lava flow.
some of that, yeah,
Might as
in
well.
just a second. So, Mr. Kyle, you let me know when to bring it up there.
Here we go. Okay, lava pour commencing. We have our infrared image going on here. Take some photos. Get surface temperature.
Yeah, lava is
Lava's about to
great.
come out
Yeah,
the spout.
I'm so glad you shared this
Come
with
down
us,
our
James. It's
trough,
pretty awesome.
14-degree trough. And it looks like it's coming out pretty warm.
There it goes.
50 Celsius.
We're aiming for
1150
So here we go on to
Celsius.
the 35-degree slope. See what we get here.
Look at the getup of this guy on the right-hand
He looks
side.
like a
of the screen.
Jedi, yeah.
He looks like an executioner Jedi.
But this is awesome.
I guess it's hard enough that even
Yeah,
though
so
there's
what's
some
cool
dry
is that
sand on top,
It
the
doesn't
water
really
from the
flow
sand
like, it's not a
underneath
normal, nice,
coming out
easy
and
flow.
it's
You get like these hot
keep
bubble
sliding,
pockets
even
and,
after- look at that,
it's
even
that's
after,
why they're pouring it. They want to see
sand
how it flows.
Yeah.
It's a
basically
cool
gone,
thing.
The top layer, it's still sliding down, and now it's filling our lava lake.
It looks
and we'll
fake.
see if it makes it
Honestly,
past
it's
that
so
or
cool.
not.
I'm like, it can't be real.
The heat it's burning. I'm amazing that's still working.
Now, I'm sorry, but you would not catch me
Anywhere near that?
anywhere near this operation. That lava is so
Yeah,
hot.
I don't think it's
Man.
gonna go much past that. It's
So you
it's
wouldn't
not
jump
really
over it?
making
You wouldn't
a
jump the
lot
gap?
because it's so steep.
Yeah.
So we're not expecting to see that. But you see how the fluid's becoming. You see how the fluid's becoming much wider at the bottom where there's that slope break. So we still have lava that's flowing through the center, and the lake is still filling, and these bubbles are piling up and making kind of different globes. See how the sand is coming up. There's some sand blasting by the lava lake. So again, that's the water that's coming out. It's escaping from the sides because it's so hot and it's vaporizing it.
It's kind of funny that they're just pouring lava.
The flow is not moving forward. The level in the lake is really rising much, but
it's
you see
awesome.
that the flow is inflating in that flat area between the steep slope and the lake.
Is this what you expected?
Not really. I actually did not expect any bubbling this time.
Awesome.
Because we didn't actively wet the sand as much as we did yesterday, for example. And I also expected it to go
like
all
the
the way to the lava lake,
fill
it, and then overflow from the lake, not
James
before.
said in the chat.
You know, that's what
Just
you
to
do
get an
experiments
idea of
for.
how
If
these
you
lava
already
flows
knew
might
what's happening, there would
happen
be no
in places
point
you can't just see them
doing an
happen.
experiment.
Makes sense,
So
yeah.
it's actually exciting that we're getting some different results, and we're going to be thinking about what that means after the flow is over and it's cooled down. We're going to take some measurements. We're going to look at the thickness of the flow on the different areas. We're going to look at the spacing among the different ropes.
I was reading up on lava flows after this just because I was curious, and some papers were mentioning how they can form like a tube, like as it hardens on the outside, there's still like a hot tube on the inside that's carrying the flow, even though it doesn't look like it's flowing sometimes.
Got it.
You get some crazy dynamics happening
Yeah.
inside the lava flow.
Well, you see it right now.
Yeah,
It's
like
gonna
it's still making its way
The
out.
morphology of that is different from up here. Up there we have what we call ropey coleoid, because you see, they're like ropes that are piling up. But here, if you look at the breakout, it's different. It's going to be more of a pillow shape.
Very cool.
Very cool. So yeah, thanks again for sharing that with us, James. That's
Much
really
appreciate
awesome.
it. Yeah.
If I'm not mistaken, I think James went and saw this live in
Today,
person
I
today.
think, yeah.
So would love to hear your experience with that. Yeah, the whole setup to me is so funny because we are overabundantly always obsessing with safety protocol. With the stuff that we do and the stuff that I do with Brookhaven and whatnot, and then you have some places where it just pour 1,000-degree lava right in the backyard, you know?
Yeah.
So, yeah, to each their own. But no, it's really cool. I wish we could do cool stuff like that, more often.
Imagine trying to do that with a high school student. They'd have to sign 150 papers.
Yeah.
And they'd have to be 100 yards away.
Exactly.
But that's all right.
All right. So let's move on. Unless you have something else to say.
Just saying we're ready to go.
Cool. Number six. Number 6 is a doozy. It's our last story for the news story.
Break it down.
But yeah, this
tough
one
for us, tough for everyone.
Yeah, we'll learn through this together. Tom, what do an octopus, a squid, and a cuttlefish all have in common?
I don't know. It sounds like a joke on an icicle pop or something.
For one,
they're squid ears.
For one, they are all coleoids, or shellless cephalopods. But a new study by Noah Liskovich-Brower and colleagues show that coleoids also make use of RNA editing to enrich the development of their nervous systems. So, let's back up a little bit. As a biological process, we understand that for many organisms, genetic information is transcribed from the double helix molecule DNA to a single-stranded molecule RNA, which is then used by the cell to make proteins that build the organism's characteristic traits. RNA editing is a process that takes place while the RNA molecule is en route to being read out by the cell, and it has the potential to, quote, modify and enrich genetic information beyond the genomic blueprint, end quote. So so let's just kind of get into that really quickly. Right, so you have your DNA in your cells, right? We have the infographic that Kyle is so graciously putting up for us. We have the DNA double helix strand that's in all of our cells that contains all the genetic information.
Yep.
When your cells are...
When you're dividing.
Right, yeah. When you're making new cells and copying over that genetic information, your DNA literally unravels a little bit. a single molecule, single strand RNA molecule will come in, copy
what it sees along
what
it.
it's copies
then-
those section of DNA, comes out, the DNA will fold back up, the RNA molecule will go about its business, where the cell will then kind of read that information in order to build proteins.
Its own,
Right?
Exactly.
Okay. So, for humans and other mammals, this is usually not the case, however. Right? Oh, I'm sorry. So, we should add one more thing.
Yeah.
So, RNA editing, right, is when if your RNA molecule, after it copies that information...
Yeah, after it copies it to go to a cell, it usually just goes right in there and, it comes together and reads it.
Right.
But in the case for these...
RNA editing sites, right? Your RNA can go to this site where it can undergo
some sort of change or modification.
Right, some modifications.
Maybe turn an adenine and A into a into a T or something.
Yeah.
To change it
up.
up. Or
Or
G
something like
or
that.
something else. Correct.
Right. So that's what we would call RNA editing, right? Is somewhere between the transcription phase and the readout phase by the nucleus of your cells to make the proteins, your RNA undergoes some modification.
In cephalopods, not in us. Right?
Well, in us too.
It does, yeah.
Yeah, in us too. So that's what I mean, whereby for humans and other mammals, this is usually not the case, however, right? Our RNA molecules don't usually undergo RNA editing. They usually transcribe and then go about their business, get read out by the cell, right? Because diversifying proteins via RNA editing can lead to less than desirable functions and thus compromise the organism's ability to live, quote, only around 3% of human messages harbor a recording site, and there are only about 25 human transcripts that contain a recoding site that is conserved across mammals, end quote, right? So this is basically just giving you some numbers to show how and why we don't, as humans, undergo RNA editing, right? It's because if we diversify that RNA code, well, we might mess up the proteins that our body needs to function, right? So that's a risk, and that's a risk that our bodies would rather not take.
Yeah, we don't need to change it up. Exactly.
Right. So instead, genetic mutations occur within the self-replication process of DNA molecules, which are then hardwired into the existing genome, right? So when your DNA is recombining, you might get a mismatched pair of your nucleotides across the strands, and that could lead to a change in the readout process of the DNA, right?
Yeah.
So it happens on the DNA level, not the RNA level for us when we
yeah.
have mutations. The study shows that coleoids are an exception to this rule. By comparing the edited and unedited versions of a protein that regulates the flow of potassium in brain cells for 2 octopus species, a squid, a cuttlefish, as well as a mollusk and a nautilus species, which are cephalopod cousins, RNA editing was shown to be especially prevalent in just the coleoids, right? So in the 2 octopus species, the squid and the cuttlefish, this RNA editing was very prevalent, right? So that's odd. Quote, in neural tissues, around 11 to 13% of these events result in amino acid modification, compared with less than 1% in mammals, end quote. Right? So that's a big jump.
From, less than 1% to 11 to 13%.
Right? In neural tissue. So we're talking about brain function here. We said earlier only about 3% overall and less than 1% in our brain cells. Whereas the coleoids will have 11 to 13%. It should be noted that the mollusk and the nautilus did not show such high levels of RNA editing. Although no direct correlation can be made without further study, the researchers suggest there is something to be said here for the behavioral complexity attributed to coleoids, for example, ability to open locks, use tools, etc., that contrasts with the much more basic behavioral assessment of other cephalopods. Right? So what they're saying is this...
so the cephalopods who developed this modification of their RNA, those are the ones who went on to be able to do these higher level skilled tasks.
Right.
Like open jars of things. Like I've seen it on TV and stuff.
Yeah.
They can literally, inside of a jar, they can like wrap their sides inside it and let themselves out. And they can perform these tasks, whereas the other ones who don't have this modification cannot.
They can't do that.
So they somehow increase their brain power by using RNA modification after transcription before it went in there.
Correct.
But this is kind of risky business, right?
Right.
A little bit.
So, yeah. So, what advantages did the coleoids gain by altering genetic information within RNA rather than hardwiring the change in DNA? Again, Liskovich-Brower et al. Offer some insight. Quote, first of all, the changes are transient. Thus, an organism can choose to turn them on or off, providing phenotypic flexibility, a quality that is particularly useful for environmental acclimation. In addition, RNA-level changes can better augment genetic diversity. With DNA, an organism is limited to 2 alleles. With RNA, all messages need not be edited, and thus the pool of messenger RNAs can include edited or unedited versions at given sites. When a message contains more than one site, complexity can increase exponentially, end quote. So what they're saying is, this is beneficial because you get way more diversity of proteins to choose from to increase the function of that particular part of the body that your cells are part of, right?
Yeah.
What's interesting to me is how do they specify what is going to be
changed and like
what is a beneficial change in the protein structure versus what is a non-beneficial change to the protein structure? And they don't know, right? They don't
really know how they differentiate.
Yeah, so that's going to be a further study. All of this comes at a cost, however. By conserving RNA editing sites that are advantageous, the coleoids significantly slow down the conventional evolution process at the DNA level. Right? So if you're withholding your RNA editing sites so that you can increase your neural functions, you're going to slow down the regular DNA mutations that
that you would naturally get.
Right. So things like appendage length, right? Maybe the squid's arm lengths will not undergo as many genetic mutations that could maybe benefit,
modify it to change it,
or maybe hinder it going forward in the future. So they're seeing that.
So when we were discussing it before, we were saying, they sacrificed that normal DNA evolutionary ability, but they're somehow have specialized to allow this plasticity in their brain function to be more important than just this normal way of evolving.
Yeah.
So we were saying it's not like they chose it, because when you read a lot of these articles, we like to put words in or feelings on the animals, but this was a pathway that was chosen to be, more. It was successful, right? The body of these animals were saying that this is good for us, right?
Yeah.
That this extra plasticity in our brain and what we can do with this messenger RNA it's better than just evolving the regular old way. We like it better this way, kind of.
Yeah. So it's interesting because I don't think any organism would find disadvantages in increasing its neural activity.
Yeah, we were talking about that.
That is just probably overall, you could say, a beneficial sort of
way to improve your functionality in life, kind of thing.
Right. But we were saying, we can't get caught up in this idea that the coleoids, the octopus, the squids, the cuttlefish.
They were like, you know what, we're doing this.
Right, they didn't hold a meeting to say like, all right, this is how we're going to evolve from here on out. It's probably more due to a genetic mutation that caused this
increase in the sites where it can be.
Exactly, right? An increase in the sites where that RNA modification can take place. And then you have to look at it as a when life gives you lemons sort of situation. You make lemonade, right?
Yeah, so the animals that had the more sites, they ended up being successful. And these modifications kept occurring and were reinforced and passed on because it was successful.
Right.
So like you said, it initially sort of just came about, it evolved that way, and then like nature selected it, that it's a perfectly fine way for you guys to exist,
Yeah.
Your appendages are kind of set where you are, and we'll give you a little bit bigger brain. That's sort of how they're going on with their evolution.
Yeah. Now, buried in all of this, Tom, I think are some pretty interesting implications where we're actually probably seeing for the first time another form of evolution, right? Evolution in a manner that happens not at the DNA level, not due to genetic mutation really anymore, but sort of
selection and recombination, forced RNA.
Forced RNA diversification that ultimately leads to kind of not mutation, but like a change that can help or hinder a species, and in this case, helps, right?
Yeah, but for now, right? In this environment,
right?
Like we were saying, so it's sort of different way of evolving, but at the same time it's still evolution, and at the same time you want to make sure you're fit for your environment that you're in right now. So it's working for them now, and it's a good way that they have evolved, and it's going to be interesting to see, down the road, maybe long down the road, what ends up happening with cephalopods.
Yeah.
Are they going to be the next big thing out there?
Yeah. Definitely a crazy story here, and I'm surprised more.
This is one of the cooler stories.
Yeah,
like a fundamentally different way to send information throughout your body and evolve.
Yeah,
there's just a different way to do that. It's like, wow.
Yeah, so life evolves. That's just a fundamental fact, because now we're seeing it in more than one method, and if there are more than one method to exist here on Earth,
then imagine the infinite possibilities.
Exactly. The implications of how life could evolve in other solar systems, maybe like TRAPPIST-1, probably not like TRAPPIST-1 to bring this all full circle. But they're very, very interesting. So I want to give image credit to Pearson Education, Inc. for the transcription graphic, and to WeHeartDiving.com for the octopus image. There is a video that I'd like to share with you guys. This is unrelated to the study, but kind of tangentially related. We're going to take a look at a National Geographic video of a giant octopus that is eating a jellyfish and possibly using the stingers as a tool. So, Kyle, you let me know when to hit play there, bud.
This video is wild.
Yeah. So the jellyfish is in there already.
He's already
eating it. Yeah.
We say this sometimes. The deep ocean almost feels like space sometimes.
Yeah, I mean,
it's just so
right. Look
so
at this.
Out there.
Look at this organism.
165 pounds. Ooh. Only grow about 12 inches in that one.
Yeah, isn't that weird?
So it actually has those little things hanging off of it still.
Yep.
Very fascinating creatures.
Very, very cool. And with that, Tom, that is all of the news. So let's move on in to Tom's Corner for this week.
Do it real quick. But yeah, so thanks for sticking around to the end of the show.
Yeah.
And let's get right into the last section.
So what's in Tom's Corner this week, Tom?
So real quick, before we get there, I just want to look at the chat real quick, because they were having a few comments about it.
Sure.
So a lot of people said makes sense, pretty cool. Helping the individual more than the species, ? Possibility. I don't know, that one's kind of tough to answer, but
yeah, so we were thinking about this also, is that we're talking more about a species-wide advantage of increased brain function, but in doing so, it kind of resets at each generation, right? Because they withhold these RNA editing sites, so when you edit your RNA, it never gets
Passed
fully
on hereditarily.
hardwired, into your DNA, and thus
That's a good point. Yeah. So you don't. Yeah. So whereas we would get from our mom and our dad, we get what we get.
right.
These guys, they don't necessarily get all that information passed on because it's not hardwired in their DNA.
Exactly.
They make it up on the fly.
Yeah.
So yeah, a little bit of a weird dynamic there. And then let me see, just make sure I didn't ignore anybody. And then, oh yeah, Andy was talking about something that he thought was a little different. Sweet. Appreciate all the comments in the chat, though.
Definitely. Thank you guys for contributing to our discussion here. Tom and I are not experts on this topic, so it's always great to hear from everybody.
That's the point I like to make, is that a lot of the topics we talk about, we're not like the expert on it.
In fact, none of the topics we talk about we're experts on.
But, you know, we like science and we read about it and we try and just tell you as much as we know about it.
Yeah, exactly.
All right. So hopefully the baby isn't in the corner. No, it's Tom's corner. All right. So, for the last section, I wanted to talk about habits, and in this case, addictive habits. So, how responsible are people for their own addictive problems, such as gambling? How much are you personally responsible for it? So that's the question they brought up. And in Scientific America, they shared an excerpt from a book that was titled The Neuroscience of Habits, How They Form and How to Change Them by Charles Duhigg. So they just took a portion of this book to try and study on.
Cool.
And in a study by Riza Habib, they studied MRIs of people watching a slot machine image of the Lucky Sevens, and they recorded their brain activity based on what the slot machine came up as.
Right.
Whether it was 777 or whatever came up. Mm-hmm. And the pathological gamblers who were in the study, half of them were having problems with gambling and others didn't. They became more excited as the slots lined up for a win. So when they got a 777, these people's excited things in their brain were like, whoa, you know, they're getting pumped. They're like, that's a win. You know, they know that thing, they associated that with winning money. Right. So they get super excited when it happens.
Of course.
So besides just being more excited, the most interesting result to me was that the pathological gamblers, they say, what it looked like a near miss to them looked like a win. So when they saw 7-7, almost 7, in their brain, they saw that as a win still, even though you lose. So their brain learned to wire as seeing almost winning to be the same thing as winning, whereas the other people's brains in the MRIs, they saw it as a loss. They didn't get anywhere near close to thinking that it's like a good thing. It's just, you know, it's not a win. It's a loss.
These would be the non-pathological.
These were the non-gamblers.
This would be
in
like
the study. Just the other people who were involved in the study.
Got it. Interesting.
So yeah. So I guess that's the big part, right? Is that even if you don't win, it's close, and for some reason your brain sees that as being associated with winning, like it's right there, but it's still a loss.
Yeah.
You know, but when you're so close to winning, don't you just want to play more? You know? Like
that's true.
That's like what it kind of is for what they're seeing in this. So kind of interesting.
Huh.
And then the people without a gambling problem were better to recognize that a near miss, you know, you still lose. They didn't get that excited things going on in their brain. So that's sort of the first part. What do you think about with that in general?
I think that's very interesting because for me personally, I feel like I have fallen on both sides of the spectrum with that, right? Where like, and I don't gamble, I don't play slots very often because I don't have any money. But you know, certain video games and things like this will make little gambling mini games within the larger video game. And when it's close, sometimes I'm like, all right, I'm so close, let's just try one more time, right? Let's get right back in there. Yeah. But then I've also felt like, you get
discouraged. Like, it's not working. It's just...
That's a loss. Got to cut my losses, right? Yeah. So I feel like I've landed on both sides of the spectrum in this sort of analogy here, which
means... you can see how it happens though, right?
Absolutely. Yeah. I think everybody would agree they could see how you would fall into that.
Yeah, in the chat, Ryan said even in scratch offs, and Mike said it's the I almost won. There's got to be coming up soon. You know, like I almost won. Next time I got it.
Exactly.
Type mentality.
Exactly.
And that's what they take advantage of. Scratch off companies. Every other card, you're one number off.
Yeah.
You're so close every time. It's that's what they take advantage of. And the casinos and everything, they're working to make it as addictive as possible. When we read these articles about what some of the casinos do, they just literally try and get you addicted to gambling as much as possible. And they even do it with things like Scratch Offs now. They're just trying to get you to buy another ticket.
Yeah.
And you got to be privy to these things.
Yeah, it's
so
horrible.
When I move on, the next part involves what people are doing, what they're claiming these sort of things have done to them.
Okay.
So the regions of the brain that they studied where habits occur are called the basal ganglia and the brainstem. So these were the two parts of the brain they were observing in the MRIs.
Got it.
So based on these studies, there have been also many lawsuits in recent years involving pharmaceutical companies, and class action lawsuits in the United States, Australia, and Canada have been filed against drug manufacturers, alleging that pharmaceuticals cause patients to compulsively bet, eat, shop, and even masturbate by targeting the circuitry involved in the habit loop. So these class action lawsuits came up. People are saying these medications basically took over my ability to function normally and caused me to be addicted from things such as betting, eating, shopping, and these things. And people have been awarded quite a bit of money in a lot of these cases, which is pretty interesting. And in many cases, individuals were awarded large sums, like I said. And a woman in 2008, in just a specific example, was awarded $8.2 million due to a gambling problem that she claimed was from medication. So she had lost a few $100,000, and the ruling ended up giving her $8 million, and she lost her own money in gambling.
Wow.
Isn't that amazing?
That is.
So this is what really drew me into it.
Yeah.
So just to finish it up, in this case and many more, the blame is put on medication affecting their habit-forming part of the brain, and they're, not my fault. They're sort of claiming that in the court of law to sort of benefit off of this.
Right.
And this neurological study points out that the brain of an addicted gambler looks very similar to someone who is affected by these medications, where, it sort of plays with this habit-forming hardware of your brain. When they see these people who are addicted to gambling, it looks very similar to people who are on medications that affected that part of their brain.
Right.
So then they're saying, when we're in the court and we're trying to, what's right, like, how much can we let everybody off scot-free,
Yeah.
It's this balance of like how much. This is why I want to like sort of get this out there. It's like once you know that they're out to get you, like then at that point shouldn't we all step back and be like, it's what they're doing is kind of messed up. Like I feel like it is, they're trying to take advantage of people.
Yeah.
But no one is forcing you to do that. I think you just need to empower yourself with what actually happens to you when you gamble and things like that.
Yeah.
So these bad habits can form before you can be like, whoa, pump the brakes. I don't want this to happen.
Yeah.
So you need to just be very conscious of what you're getting yourself into.
So education then is key, right? You need to be informed of the fact that, there is addictive nature to things like gambling, and that, just gambling one time can actually
affect your brain.
Yeah, alter your brain chemistry. And B, you need to be aware of the tactics that the business of gambling will use on you in order to take your money, in a sense.
If you look at it, they're it's just designed to make money, right? Especially slot machines, like everybody knows that.
Yeah.
You put the money in, more money goes in than comes out, and they make money.
Yeah,
That's the way it works.
Now, I think that there's something to this in the fact that the individual needs to be responsible for their own kind of, dipping their feet into these sort of games
things,
and
yeah.
I mean, the analogy I drew up when I was thinking about this earlier is that I drink coffee, right, habitually now because
basically every day.
Yeah,
it's just,
because
it's part of your routine. It's a habit.
Part of my morning routine. It's
changed.
Because caffeine, right, has altered my brain chemistry that to the point that I am addicted to it.
Yeah, but, it's where you would struggle to function without it, right?
But, and I, just being me, tend to add, milk and sugar to my coffee every morning. So, but would it be fair then for me somewhere down the road to say, oh, I developed diabetes, I'm going to blame it on Folgers.
Because I got addicted to coffee.
Yeah.
And I put sugar.
It
in there.
wasn't my
Yeah.
fault because they altered my brain chemistry. So I should be totally I should be awarded money. Like,
Right? Isn't
I
that
kind
funny?
of don't really agree with that. And I understand that, you know, I look at gambling as kind of a shady, like, thing that humans do. Like, I don't really want to get into
I remember
gambling.
the first time stepping into the floor and I saw it and I was like,
Yeah.
this is real. You know, like, oh man.
Yeah, I
but
mean,
it's awesome. Yeah.
Among friends, like, yeah, it's fine. We've played poker in the past. It's awesome. Yeah, it's a fun night to spend, you know, with your friends. But I feel like when you step into a casino, I almost feel like you sort of don't have the right to claim, like, you know, your brain was altered by the gambling when you willfully walked in there, right? Like that. Nobody forced you to go play slots.
Yeah.
You know? So, I don't know. I think that there's something to be said for that.
So we're going to wrap it up just about now. Yeah. Want to see what comments are on the chat?
Yeah, certainly. So, Chris Dudo said that he's got to get a doctor to hook him up.
With some of that.
Yeah. I know about some of his gambling escapades, I guess. Escapades. I can't say that word. Let's see. What else?
Yeah, like Andy says, the odds are they're stacked against you. Everybody kind of knows it going into it.
Yep. A lot of people agreeing with us here. Chris is wondering about if the same goes for sports gambling, because there's so much more critical thinking involved prior to making decisions and placing the bet than just leaving it to chance at the casino.
Yeah, so there's
That's
probably a
fair
different
point.
from just pulling a lever and then betting on a game. Where
Yeah.
you know all the stats of all the players and a lot more goes into it.
Yeah.
I would say it's probably even more complicated than at that point, but
I look at sports gambling and playing the stock market as
Kind of the
two
same.
things that are ultimately the same.
like
And
you can know a lot about it, but it's still way beyond your
Yeah, but I
ability
think
to
you can-
accurately predict. But you
can make better decisions with the information that is available to you if you so choose to look that information up. And I think that is more in line with something I would agree with. Yeah, I think that's about it.
Yeah, so just to bring it up, we were talking about how much money these people are awarded and stuff. That's what really drew me into this. Like,
Yeah.
everyone's like, not my fault. Now you got to give me money. You did this to me.
Yeah.
I'm like, how is that successful in the court of law? And people have made money off it. But I think over time, as we learn more about it and this knowledge is out there, I don't think you're just going to be able to be like, it's not my fault.
Yeah.
They did this to me. You know, like, I think we're sort of getting beyond that.
Yeah.
As time goes on, like when Mike said in the chat too, like someone spilled coffee on them at McDonald's and then they sued, you know?
Yeah.
Like I think we're sort of kind of putting the burden on the consumer to know what they're doing.
I agree.
As the future goes on.
Yeah, you can't.
But you got to be careful, you know? You got to know that these things can happen, and habits are just that. You can have a bad habit out of nowhere.
Yeah.
So you got to just be aware.
You can't sue Big Tobacco for
Not
for
anymore,
getting
yeah.
cancer, right? I mean, yeah,
put it
the
on the
information's
box,
out there.
yeah.
They put it on the box. All right, well,
Thanks for stopping in. What a good episode.
dude,
I'm feeling it.
awesome episode. Great topic for Tom's Corner this week. I really enjoyed it. Definitely some food for thought there. Thank you guys all for joining us this week.
Yeah, I love the chat too.
Absolutely, the chat was amazing this week. We will be back next week, so we hope to see you then.
And there's a NASA press conference on Thursday, so
Yes.
we'll be sure to break it down.
Absolutely, I'll be watching it. You guys will get some updates on Facebook from me and maybe some live tweets from you. So yeah, we'll see you. We'll see you then.
Thanks, guys.
Take it easy.